Okay, let me introduce our next speaker, Charlie Polly. Hey, how are you?
Hi, Neri. I'm good, and you?
I'm fine too. Uh, please give us a brief introduction about yourself.
Yes. So I'm Charlie. I'm currently freelance front-end architect and also a tech lead coach. In the past, I worked for many type of startup, like early stage, mid-size, but also big one like Dashen and Algolia. And today I'm going to talk about like maintainable React and especially how to deal with technical debt on different typology of React application.
Thank you. I wish you luck. So you can share your screen and the stage is yours.
Yes.
I will be
Yes.
here.
Thank you very much. Yes. Up. I think you see my screen. I think it's okay. Let me check if it's okay. Looks okay. I guess it's okay. So, hi everyone. Let's start. So the title was Managing Technical Debt on 1 year for 1 year multiple React SPA. I was supposed to present one specific project, but I changed company and I thought it would be like more interesting to present like many type of projects with patterns of technical debt on React SPA that I faced in my career, in my 9 years of experience working on the full stack with React and other type of application. So again, small introduction. So I'm currently freelance, but I've been working like for 9 years in startup only as an employee, different type of startup like early stage when you have to build everything from scratch for mid-sized company, at least in Europe, in France, which is like around like a 50 engineer, and bigger company when you're like close to 100 or even more engineer. On the side, as you may guess, I'm a speaker. I spoke at many conferences, Geeko. This is my third Geeko conference on React, and I'm also writing many posts, publication. I will talk about this later. And so in 9 years, I've been facing a lot of technical debt challenges, especially on React. So today we're going to take a look at some use cases and some takeaways that I hope will help you better manage your technical debt on React application. So before starting, let's make sure we are all aligned on what means technical debt, because it means a lot of things and people have a lot of different like opinion on what it means. So let's try to make sure that when we talk about technical debt on React, we don't talk about like old code or basically code that we don't like, that is not optimal, or dirty code, code that we don't want to understand. But I would prefer that we talk about like technical debt, about code that results in poor user experience because of performances. For example, like we have a lot of re-render, or we are struggling to make animation because of bad library choices, etc. And this end up like having like a business impact on the user experience, but also the degradation of developer experience, meaning people working on the code source. So this can be linked to dirty code, but I would say, okay, dirty code only if it degrades developer experience, meaning that people struggle to develop new features, or it's getting slower and slower to add new feature to the code base, or even worse, which is a direct impact on the business. It triggers some churn. So of course, in ideally, technical debt is mainly code issues that have a direct impact on the business. But also there is this third category that I've put that is like bad code course, which is anticipating well-known facts about technical debt, which is, for example, like keeping dependency or kind of routine that you have to do at least multiple times a year, but are not linked to specific part of the code, like keeping your dependency up to date. So now that we are all aligned on what means really, at least for this presentation, technical depth on React application, let's talk about some use cases. So before starting, some disclaimers regarding the use cases I'm going to show you. So of course, now I'm a freelance. I work for many companies. As you know, there is like copyright and things about like what you can show or not in private, especially in the private startups ecosystem. So I'm not going to be able to show you real UI and real code example, etc. So what I decided is to take two strong patterns that I faced in many companies and show you like the basic ideas and anonymize things, but the essential information will be here, don't worry. So we're going to take a look at two main patterns, if I can say, which are use cases. So the first one is technical debt when you have to migrate to a new stack, basically completely change your technology. For example, going from REST to GraphQL because you are facing some limitation in this is like very, very strong technical debt, but also changing other type of architecture. For example, you want to move your whole application that have like more than 500 components from Mobix to, I don't know, Recall or other state management or just React context. So this is a very, very frequent thing that you can see in mid-size, I would say like A series, A level, like, sorry, it's my phone, A level, like a company that are A round, yeah, AC round, and also like very small startup that just had a bad start. And so we'll take a look at this first use case. And the second one is a very interesting one, is what I call unstructured application, which are basically just React application that has been started like very fast, just adding features on features and features without taking time or without having the expertise internally to actually structure the application with a good architecture or minimal architecture that will guarantee to not face some typical like performance issue related to state or routing issue or any kind of architecture issue. So let's talk about the first use case. When you have a type of debt that requires you to migrate to a complete new stack or new technology or to change the architecture of your React application. So in my experience, I've been facing this exactly 2 times and exactly the same pattern, different technology, but exactly the same pattern. And the initial need was to migrate from REST to GraphQL on an application that have like 100, dozens of features, 100 of components, and yeah, very complicated to migrate. So this company was a company that was doing like, let's say, for example, like a typical like a to-do list and a typical UI, for example, when you have like a list on the left and then on the right you have a panel for the active item you're reviewing right now. So like you have in Height, like you have in Jira, like you have in Asana, in any kind of a project management tool. So this application was built using REST initially with a homemade client-side data store over Mobix. So the data was taken from REST API and put into a Mobix custom library that was handling all the caching of the data, but also the offline, etc. And Mobix was also used for state management. And very fast, they reached maintainability limitation by using this homemade thing built by one person, undocumented, and the typical like way of issue of growing a company to a many hiring new people and trying them to work on something that has been done internally. But also the main reason was performance limitation. Like a lot of modern React application, ASPA, you want to have to display a lot of data at the same place with a lot of context that comes from different resources. And this is a typical kind of problem that GraphQL can help you solve when you're using REST API to stop ending up like doing a lot of individual call and having to crunch the data manually on the front end, etc., etc. So the initial will was to migrate to GraphQL. So what they did is that they rewrote completely the API in GraphQL, like with the same features. And they, once it was done, they were like, okay, so now we're gonna migrate. We're gonna have like this direction in terms of technical direction. We're gonna go from REST to GraphQL API. We're gonna drop completely Mobix everywhere. We're gonna use Apollo GraphQL client for the data, and for the state, we're gonna just be simple and use hooks to consume the context values for everything that is not related to data that will be in Apollo GraphQL client cache. So just to remind you, the API was existing with all the features. So we have 2 API, one REST API, one GraphQL API in production ready to be used. And what the initial approach before I arrived on the project was to say, okay, let's migrate. On the front end, let's just start by migrate the main component and see what happens. So we're going to take the list, which is the list of item, and we're going to migrate it to GraphQL. And this technically ended up to a very interesting situation when the list was taking data from GraphQL in Apollo while the active item and all the parts that were not, that were still visible in the UI, but not part of this component, were relying on the data from REST API. So of course, very, very fast, we end up having like mini UI discrepancies, a lot of bugs, and very, very hard to solve because we had to make sure that we get data from 2 different data sources and make sure that there was no differences anytime between 2 libraries that doesn't handle the way of refetching, updating state the same way. So it took a long time and the result was not very here. So I decided to propose a new approach to continue to migrate the front end. So my approach was to do a top-down migration, aka like a data-first approach. So the idea was to, before making any UI changes, make sure that we have all the data that we need to migrate the feature. So it sounds obvious, but this is a step that has not been taken in the previous approach and led to many issues on the UI. So my proposal was to have the following step in terms of strategy. First, to identify what are the core application lifecycle data dependency. So what I call like core application lifecycle data is users. If users belong to workspace, if you have feature flag, everything it is like top level and required to start the actual application, no matter which feature you use. And then once you have that, you identify that for each feature, identifies the data dependency, and then have a map of basically each feature and which data needs to be migrated so we can migrate all the features. So basically have the link between the UI and the data. Once you have all these elements, you can lay it on a roadmap. And then for each new development, because you cannot freeze like your company and say, okay, we're not going to add new features for months while you're going to migrate everything. We're going to have like guidelines. But every time we migrate a feature, we're going to reload change behind a feature flag. So we can like, for example, release for a specific non-critical, for example, user or beta user and proper monitoring. So let's take a look at this approach, the data-first approach. So the first step is to do basically auditing and planning. So as I said, we're going to take like the core application data with the user, etc., and we're going to list everything and make sure that in a ticket we have a good design view of what work needs to be done in order to migrate this core application data in the actual application. And then we're going to do the work for each feature. And then, as I said, with the map, with mapping all different dependency, we're going to be able to have an actual roadmap. And for example, having the map of the dependency between features and be able to cross it with the data that we have from the product team regarding the criticality of the feature on the business. And we're going to be able to have a real prioritization of the work that needs to be done in quarters. The second step is, once we have a roadmap, is to actually do the roadmap, so do the work. So for example, when we're going to migrate a feature, first we're going to migrate, as I said, the data, then the UI. So here, for example, we want to migrate the panel on the right. So we're going to take a look at the different data dependency. We need the current user. So this technically is already available because we already migrated the core data application users, workspaces, feature flags, etc. But we need to have access to the to-dos and a lot of data. We're going to make sure that we add all this data and mutation required in GraphQL files so we can generate TypeScript types, and we can have everything ready and we can ship in production first this part of code, review it, and look at the UI. Then we're going to take a look at the UI. So in this specific project, the migration was especially difficult because we had to migrate from REST to GraphQL, to class component to functional component, and from Mobix to hooks. So it's 3 different types of things that are quite linked together and very hard to uncouple. So what we did is just to make sure that we first take class component and look if we can migrate them to functional component. If we can't, wrap them in functional components so we can pass them through props hooks, and make sure that we can get the data, the REST data, through a hook and then change it later. So here we have like a classical like inject Mobix when we get all the items, and we have like items.active to get the active one selected. And then we do like the simple migration to make sure we can move fast and put feature flags. So here we remove the coupling. So here, this is a use case when we cannot migrate completely the component because the UI is too complex. So we just do the data, and later in future iteration, we will take a look at migrating completely the UI. Finally, once we have everything ready in GraphQL in the data store, in the cache, and we have like all the hooks that are using for now like the REST data, what we can do is just switch the hook, or put a feature flag on the hook. So a feature flag is just basically reading a Boolean value that's going to say, oh, should we, for example, we're going to have a feature flag, a list of feature flag, which are just like variables that are linked to your API and refreshed over real-time WebSocket all the time. And basically those variables are going to say, for example, we're going to have like active panel GraphQL true or false. And depending on the feature flag value, we're going to get the value from the Mobic store or the GraphQL store. And this kind of live or not, depending on the application of doing so. So here we have our component that doesn't care about like whatever the data comes from REST or GraphQL. The hook is responsible of getting the data and returning like a standardized data. So this is a simple use case when we can just change the way we get data. Most use cases, it's more complicated. We have to completely rewrite all the UI, but this is the same idea. Instead of doing the switch at the where we get data, we do the switch at the component instantiation. So we completely switch with the feature flag the UI completely and the data or just the data. And then finally we release. So we have a feature flag, so we can deploy the code. We can change the feature flag value. We can only deploy to internal team, to internet team plus beta tester, and look on the monitoring. So this is an example of a custom monitoring I did put on this project with Datadog. So he was helping us to see, for example, what are the user repartition. So because with SPA React application, when you deploy a new version, it doesn't mean that your user is going to run on it unless they reload the browser. So it's interesting to have this information here to know if you deploy something, people are actually using it. You have the difference between like JavaScript errors and network error, and you have app crashes thanks to React error boundaries. And here we can have a good overview, for example, that if we just deployed something, we can see if it has an impact on production very fast, and if there is a trend of something not working without having to rely on bug report from users. So let's sum up this first. So here we have a big project when we want to migrate to a new stack, like the network layer stack, and also new architecture because we change completely the way we order state in data. And we use this data first approach that allowed us to, of course, slowly but surely migrate all the application piece by piece in an iterative way, first by doing auditing and planning. So looking at different dependency and then migrate safely with feature flag and feature by feature and with monitoring to the user the changes. So I will do another conclusion at the end about like the different takeaways. Let's take a look at the second use case. So now we are going to take a look at the complete opposite. We just saw like technical debt because of architecture choices or architecture changes or over-engineer architecture that we need to change. Here we're going to take a look when there is no architecture, and this is a main issue of why there is technical debt on all React application. So what I call unstructured application, React application, are applications that are built empirically, that evolved along the product complexity without consolidation or architecture work, which is what a lot of companies do because of lack of funding, because you don't have enough engineer, or because time to market need to go very, very fast. Or the second use case, which is also very common, is applications that are initially built by solo developer or multiple freelancers that did like a bit of work, like feature by feature, or even like non-front-end developer, people from the API that were asked to do like front-end very fast. And then basically the front-end that was supposed to be simple became like a real application kind of. And this kind of unstructured application leads to several type of issues. First, the very, very, very common one is state management. And not necessarily the choice of state management library, but the usage that is made of the state management. For example, the lack of immutable data, the use of the bad use of context value, for example, passing like a new reference of a new context value every time, or a lot of things linked to state management I will talk about just after. Of course, many bugs linked to the lack of state consistency and test coverage, facing challenges to improve the non-initial maintainer velocity and ownership. So basically, facing challenges to onboard new people to the project because there is a lot of structure, and the structure is only in the mind of one person, which is the initial or the small group of initial developers. And of course, slower iteration of the code base because of increasing bug and perceived complexity. So this is something I saw many times. So we're gonna see what is the approach I use in this kind of situation to tackle this kind of technical debt. So the proposed approach here is to do a audit and then guideline and roadmap. So my typical audit methodology is to look at different sections of evaluation of thing I'm going to audit. So like state and management, photo structure, component design, data architecture, LinkedIn, UX pattern, typing. And then once I have my audit that is very exhaustive in terms of like detail, I'm going to be able to put guidelines for new development and a roadmap to redeem the technical debt. So this is an audit example. So for example, looking at the code base and be like, okay, basically there is no unit test, there is no coverage, there is no end-to-end test. Basically, there is no test on your application. So this is something that could be interesting to look at. There is a lot of performance issues. So this is very specific and hard to get what is the initial issue. But regarding performance in general, for example, there's a lot of lack of there is a lack of use callback in the component. A lot of dependencies are missing when using React hooks. So this is the small things, and that can be fixed very fast with guidelines, for example. An interesting one is TypeScript. TypeScript sometimes is used in project without strict mode, is not enforced in the CI, and a lot of any and as usage. So TypeScript, when used properly, can lead to 15% bug reduction, theoretically. But if you don't use it properly, it's just going to slow down your compilation and your deploy, and also your velocity because it adds some overhead. So it's very important that if you take the decision to make the decision to use TypeScript, you use it properly to take full advantage. Otherwise, it's going to be just something that's going to slow down everything and lead to a false impression of security. Also structure. So this one is more like to boarding new people, like what is the structure of the app on folder, on component structure, on naming convention, and also data architecture, which I'm going to talk about. So what is data architecture? Where is stored the data? How do I get the data? What is the data needs to be, does the data needs to be loaded lazy everywhere, or can we make sure that somewhere when we reach certain features, the data needs to be here? And it's impossible that, for example, the current user is missing in the authenticated part of the app because it's handled at the top level in the upstream of the routing. So this is nice, but an audit is an ideal architecture proposal. This is not a realistic thing in the business of a startup. So what we want to do is to lay down from this audit a strategy, which is going to be a combination of the audit, the allocated time of the, meaning like the number of person of your team, and the time you want to invest into technical debt, and the priority of the company. So this is more like for what needs to be done first in order to improve the company issue first. And then from a strategy, we're going to have like a tactics. So the strategy is the concrete application, is the concrete view of the audit applied to the company. And the tactic is how we're going to apply this strategy, like really to the company, how we're going to ship all these things in a very detailed way. So the approach I like, and I'm going to talk about, is guideline principle mapping. So deliver changes in 2 steps. First, set up guidelines for upcoming work, because as I said previously in the previous use case, we are not going to be able, most companies are not able to say, okay, we're going to freeze everything for 3 months, for 6 months, and we're going to do everything that has been advised by the audit. So we want to have new features. We want to make sure the business is running. So we want to set up guidelines for upcoming work to make sure we don't add more depth with new features. And then we're going to lay down a roadmap for existing code that's going to be prioritized given like the time allocated, the size of the team, also the priority in terms of like a dependency of different things to do, and also like the business. So let's see an example of tactics, meaning applying to this hypothetical company, anonymized company, the strategy of guideline plus road mapping. So the vision of what we want to do is we are working in a company when we want to improve the stability of the code because we have a lot of bugs, and we want to improve the developer experience, meaning like the velocity, maintainability, make sure the code is easy to read and making it easy to onboard new developers. So first, we're gonna have a set of guidelines. From the audit, we're gonna keep only a subset of things that are feasible to do in a given time in terms of guideline and roadmap. So in terms of guideline, we're going to put a testing strategy. For example, we're going to say, okay, now everything that is done needs to be unit tests at the hook level with the 80% test coverage, and we're going to write end-to-end tests for the shadow testing. We're going to test the critical parts of the application with end-to-end tests with Cypress or Datadog or Preflight. And then we're going to put guidelines for the component design. We're going to make sure that we don't have fat components that do everything. We're going to extract the logic into custom hooks. We're going to have like proper, easy to read, proper decomposed component as a guideline for the future features. And then a roadmap for existing code. So the roadmap is that, okay, the thing we're going to actually really rework in the code right now to improve stability in the developer experience are data architecture and typing. So let's see an example of guideline. The guideline that I often advise to companies that have no structure and no strong appetite of running like big scale kind of React application is to do slim components and to test in isolation those the slim components, so the extracted code. So for example, let's take a look at this UI. So we have a simple list of article with tabs with different type status of articles. So either derived, published, or archived. The corresponding code is the following. So here we have like a very typical React component when we have like the JS6 part at the bottom, we have the use state, and we have a lot of custom thing to load the article. So my take on that is it look already a bit messy, and this component is very simple. So in order to make sure it's going to scale, we're going to keep this component slim. So what I call slim component is to make sure that your component is calling hooks at maximum and that there is no custom logic unless it's really UI and not very, very small in your component function body. So we go from this kind of approach to this kind of approach. So basically, our article component is going to make use of useState for the current tab, and then we're going to have a custom hook that's going to be responsible of loading the articles, but also doing filtering using this, for example, like guideline that has been introduced by Apollo with the hooks. When you have like something that loads data, it returns you like loading, error, etc. A roadmap example. So something that we're going to do as a project, as a refactoring, data architecture. So have a look at the data architecture of the application. So we want to make sure we have a clear data flow in our application, that we have like one data store. We don't have like multiple data store, that the data come from one place, that we avoid loading data directly from the UI component, that we use custom hook with clear API, with a clear signature of function, that global data can be accessible synchronously, like the list of current users, the list of workspace, the list of feature flag, and we especially avoid like props drilling. So let's see an example of a fake application. When I say like hierarchy of data, I'm talking about this. For example, here we have like a chat application with a chat list on the left and the active chat on the right. We have the Apollo store and we have our app. The app is going to be responsible of loading the workspaces. So make sure that workspace, the current one, the component is instantiated only when everything is ready. When the app is loaded, when we have like all the workspace, we know which one, either from the local storage, which one is the active one given the previous session, or take the first one, or any custom rule on the backend that we get from the GraphQL API. And then we instantiate workspace, which is the current one, which is going to load like the users of the workspace and instantiate the chat once everything is ready. So we don't have to, at the very, very small component, for example, at the least, we have to wait on asynchronous thing everywhere and create like complexity of having to have like asynchronous code everywhere. So here, for example, you're going to say to me, okay, the performance, what about the performance? It's a lot of loading. You can definitely move, especially with GraphQL, the logic of loading the current workspace and the associated users of the current workspace at the on one top level above at the app component. Yeah, so you end up having this kind of thing where you can get synchronously global data like current user, current workspace, and current chat. So let's conclude because I'm a bit late. Let me check if I'm late or it's okay, it's fine. So conclusion, the approach, whenever you're facing issues of architecture, you need to change your architecture, your stack, or you need to set up an architecture because you have depth linked to your React application architecture, can be done in 3 steps. And especially, I will really advise to not run into this kind of project and think about using these 3 steps. So first, set up a vision, define what is your technical depth. Then really define it. What is part of the technical depth? What is not? What is your problem? Then have a strategy on how you're going to tackle this problem. Like, for example, like the top-down approach or the audit roadmap and guidelines. And then tactics. Make sure that this strategy is have a very good execution in your application, in your team with ticketing and road mapping and in your quarters, etc. So we saw for the first use case, we want to migrate to GraphQL. That was the vision. The strategy was to have a plan and iterate data first approach. And the tactic was to migrate core data, then feature by feature. For the second one, we wanted to add architecture. We want to structure the application and especially improve developer experience and reduce bugs. So the strategy was to do testing, slim component, review, rework the data architecture and the typing. This using a tactic of doing first guidelines for new development and road mapping for everything regarding refactorings. So to really sum up, for migration to a new stack or new architecture on existing application, don't rush into big migration. Think about it, do an audit plan and migrate in many steps. Think about safe releases with isolation of your migration in multiple PR behind feature flags and proper monitoring. If you want to structure your application, think about like having guidelines for new development and then doing roadmap for existing code. Readability is very key for developer experience. So making sure that your code is very easy to read. So this is for like ability to scale in terms of human your application. And then stabilize your code, your custom logic with testing and isolate your custom logic into some hook that you can test. Those are very interesting articles if you want to go further. State collocation article from Kent C. Dodds, because most of React application performance issue and depth are linked to state. A very good article that explains the vision, strategy, tactics thing from Jacob Kaplan-Moss, creator of Django on the Python community. And I wrote also an article about maintainable React in many articles that explain some rules, very more like code oriented, about how to set up good maintainable code. So it's a lot of content from this presentation. Final word. So this is my website. I publish a lot of articles all the time on React, TypeScript, GraphQL. The last one is, for example, a lot of advice and a feedback on how to use TypeScript with GraphQL properly, how to configure everything, make sure you have very strong type that doesn't require a lot of maintainability. You can find me on Twitter, so where is Charlie, and also small promotion here, but I'm also available as a friend, as you may know, for this kind of work if you're struggling and you need help. So yeah, that's all for me. I hope you enjoyed it, and if you have any questions, there is a Q&A right after.
So thank you very much. It was informative. What's your feeling after the speech?
Sorry, can you repeat?
What's your impression feeling after the speech?
I feel like it was a lot of content. It was shorter when I was like rehearsing, and but yeah, I feel it's okay. And I guess they're gonna have maybe a lot of small questions because I went very fast on a lot of things, but I think it was okay overall.
Was it
What
your
was your
first,
impression?
was it your first online conference?
No. I did so 3 years ago. I did a React Europe conference presenting like a project. I stopped since, but maybe I will continue maintaining soon, which is basically a form library based on GraphQL that if you provide like a GraphQL mutation, it will automatically provide you everything you need to build your form using like the GraphQL introspection and the types in GraphQL. And I did like a lot of meetups in Paris because I'm from Paris in France, 3 Geeko conferences and some other conferences also online. So yeah.
That's nice. Do you prefer offline or online conferences?
That's interesting. I think I prefer. I think I like both, but yeah, what is missing, not with Geekle because we have the Q&A right after, which is good, but some conferences don't have them, is the interaction with the audience, the ability to see people and to see the reaction. I think it's more peaceful to be online because you don't see people, so you don't have like the pressure of, oh, people are don't listening, or am I not interesting, etc. But the offline experience is also interesting because you can directly interact. You can have like a long talk after with people and really go into details. But this is also possible. Don't hesitate to reach out on Twitter, and so we can talk about it in more details.
Yeah, for some speakers, it's much stressful if the conference is offline. Okay, thank you, Charlie. We will meet you soon in a few minutes. Just one more note. If you have any questions, guys, please leave them in the chat. We will get back to that question soon.